Hello guys, welcome back to my channel DP Design, and in this video we are going to learn how to do a CFD simulation of a Le Mans car. So as you can see, without wasting time we will move on to the modeling part. So in the modeling part you have to consider each and every surface to be solid. Okay, if there is any one surface which is not solid, then it will interrupt in CFD simulation, and also you will face the errors. And yes, it should be have a watertight model, so you should check before doing the CFD simulation. Also it is checking automatically sometimes, but it is not very accurate, so I think you should, if you check by yourself, then it will be very good. Okay, now I will do the section view. As you can see, this is the solid model of the car. There is no surface involved in this right now. Okay, after making surface model, you can just give the thicken, so you will have the 3D model of 3D model of the car. Okay, so we will move on to the flow simulation. If you don't have the flow simulation in this tab, so what you can do, you can just go to the add-ins table and you can add on whatever you want to add, like a simulation, flow simulation. Okay, and you can just tick mark. And also at startup, if you want to make this turn on, then it will delay the 1 second. Okay, accordingly, so you can make it okay. So there is a plugin of a flow simulation in add-in, so you can turn it on. So first you have to save the model before starting the CFD. Okay, my model is already got saved. Now you can go to the wizard. There are lot of input data and the result data is there. So in input data, first we will move on to the project name. Let's say I'm giving the Le Mans CFD. If you have any display configuration or any other configuration, any dimensional configuration, so you can just select your configuration accordingly. For me now it is current only. I will not change any configuration in this. So if you also if you want to add any comments on that, any description which you want to add in the report automatically, so you can write down those comments or description in that. Now the unit system, I will use the unit system which is a system international. Okay, predefined. And manually, if you want to change something by the distance, temperature, physical time, whatever you want to change, you can change from here, right? Okay, we are done with the units. I will not change anything in the unit system. Now fluid flow should be there. You have to define your simulation is external or internal. My simulation will be external because it is an open body. There is no closed environment involved in this, right? If I want to do a wind tunnel simulation in a closed loop system, then I have to make the model of wind tunnel, and I have to put the car in the wind tunnel, and then I have to do the internal simulation, internal CFD simulation. Okay, so right now I have the external simulation CAD boolean. Okay, extrude CAD without condition. Okay, now conduction is not there, time dependent is not there. It is a steady state simulation, not a transient. Gravity, you can just make it, turn it on. Okay, if you want. Rotation. Okay, coming to the rotation, I will explain you the later how to rotate these tires. Okay, during this CFD simulation, it is kind of a difficult process, and also it will involve the more time into the simulation, so I will not tick the rotation for now. In previous video I have taught the how to make rotational region, how to make assembly. Okay, so you can just check those video, otherwise I will show you in the next videos. Free surface is not there, free flow is not there for now. Okay, gases. In gases I will include the air for now. Okay, if you want to add liquid, you can add liquid. Okay, there are a lot of options are there, but for now I am doing the aerodynamic simulation, so there is no water involved. Okay, there is only air. Now flow type is a laminar and turbulent both. not turbulent, not laminar, but both. In starting it will be a laminar, but when it will touch the body it will get turbulent. Okay, so yeah, humidity values I don't have, so I will not input that humidity for now. Now the roughness of the wall, roughness I don't have the value. If you have the roughness of the surface, then you can just click here and put the RA value there. And default wall thermal condition, adiabatic wall, which means no heat transfer. Okay, coming to the main part, main boundary condition, which is the last tab. Okay, in that you can just put the pressure, temperature values of the environment. Okay, so temperature is okay, pressure is okay, and velocity. Velocity, how much velocity you want to apply, right? If you want to apply 100 kilometer per hour, 200 kilometer per hour, whatever. So you have to see the direction. My coordination system in is this direction, y direction, minus y direction. It will air will be the flow of the air will be in the y direction. So in y direction I will apply the velocity, which will be 200 kilometer per hour. Okay, it will automatically convert into meter per second, so there will be no issue. Turbulence parameter, if you have a specific turbulence model parameters, then you can add into the turbulence intensity and turbulence length. And there are another option is there for energy and dissipation, but I don't have a particular values for now, so I will keep it at it is, because it will not change much in the output. Okay, so accordingly I have defined. I will take a finish. Now after finishing this, you will get a computational domain. Okay, which is very weird now. So what you can do, you can just manually adjust the computational domain from side view. I should adjust from the bottom like this. From front it will be like this. Rear it will be 18 mm, I think 18 meter. And on the upper side, okay, it's enough. And now, okay, how much computation should be, that I have already posted on my Instagram channel, how to calculate the computational domain according to your model. Okay, and according to the speed. So that I have put it the blockage ratio, as you can see. Now coming to the goals part, we are done with the boundary condition for now. You can save the model, and in the goals you want to take a down force, you want to take a drag force, or you want to take a friction force. Okay, whatever, if skin friction, drag, whatever you want to take, either surface goal, point goal. So I will take global goals for now. Okay, and I want down force. Down force means in the z direction, and drag force means y direction, and side forces will be in a x direction. Okay, so as you can see, there will be the forces, the normal force. Okay, also there are a force, and normal force you have to take for a down force and drag force. So in the y direction and z direction, y direction and z direction will be my down force and drag force. So in x, it is in x direction. Edit definition, normal force y and z direction, y, and this will be my z direction, z. Okay, so in z direction it will be a down force, and this will be a drag force. So accordingly you can just click whatever parameter you want it as a output. So you can click it OK, and it will be on the global goals. Okay, so it will be overall goals. Now coming to the surface goal, let's say you want to take downforce on particular surface or particular wing. Let's say I want to put uh, I want to measure the downforce acting on this wing. So what you can do, you can select two surfaces and select the whatever forces you want. I want to take a downforce on this wing, so on the z direction you want, and OK. SG means surface goal, rear wing downforce. That's how you're gonna make it the goals, the output. Okay, and the equation goal, in equation you can make the CD equation, means coefficient of drag equation. You can involve these all parameters and it will automatically calculate the coefficient of drag. That I have already explained in the previous videos, so you can go check that out and put the equation instead of putting the values in the calculator, right? So it will be easier to find the coefficient of drag with the design. So if you have many design, you can just put in line and you can see whatever difference between just designs. Okay, now coming to the part running. So I will go to the calculation control parameters. You have to double check if everything is okay. Goal convergence, all goals. Okay, iterations, it will be automatically. Travels also, it will be automatically. Calculation time I don't want to define because it is not the transient, and I have not defined any calculation time for that. It will be a purely computational. Okay, so it will take automatically. Refinement. Okay, so you can just choose refinement according to your simulation level. For now I will disable because I don't want much accurate result for now. I just want to get it solved. Also time step setting, it is not applicable for this kind of simulations. Saving periodically, so it will save every image per iterations. Okay, if you want to save full results. Okay, so that's how you can click it OK and just make it run. You can see the pop-up is there for simulation, mass capturing, preparing the calculation. Also you can see the plot from here. Let's say I want to see the top plane. Okay, and you can see what is happening in the top plane. I want to see the side plane, right plane. Okay, and in the right plane you can see here, and make it bigger. You can see the pressure difference is there. You can see the graph as well, how much it is converging. Okay, the convergence will happen after some time. Right plane, front plane will see. Okay, also you can select the parameter. As you can see, it is the pressure, but instead of pressure, if you want any other parameter like a velocity, so velocity you can check, there is no issue in that. Right plane. Also you can see the iso lines, minimal maximum values. Okay, so see, this is the velocity, this is the turbulence building behind the car. Okay, maximum velocity is going about 65 meter per second. Iteration is happening around 106, 107, 108. Okay, it is getting calculated. Till then you have to wait. You can also save this image. Okay, this is 640 by 480, but you can make it bigger. Image attributes, you can make it user defined. So if you want to show or put it in a report, so you can put it in reports with a higher resolution. You can also click the save images, so it will save the every iterations image or video and meshes also. It is very good option while interpreting your result. During your interpretation of a result, you can also see what is happening in the simulation. Okay, in other software I have seen there is no such privilege to see what is happening behind that. You can just see the iterations, you can see the graphs, you can see the conversions, but you cannot see graphical interpretation of different parameters. Like you can see here as velocity and pressure is happening right now. Okay, so we will for now we will enjoy this graphical interpretation, and we will wait till this calculation is getting completed. Okay, I think it is getting completed because we have not defined any refinement for that, so it will resolve soon. Okay, done. If I go to this panel again, so it will tell me solver is finished now, and see the time it has taken 2 minutes only, no problem. Iteration per one travel 81, travels 1.60. Okay, done. So you can close it and you can hide this computational domain. In the result you can see 2.fld. What is that? 2.fld is a file has been created into that folder, so that you can access those file as an input of FEA analysis also. Okay, that also I will teach how to combine the CFD and FEA both together. Okay, so now coming to the this post processing part, you can see the cut plot. Cut plot, I will see the side view, means my right plane, and click it OK. It is a pressure, but I don't want to see the pressure, I want to see the velocity. Velocity you can see, yes, maximum it is going above 664 meter per second, and yeah, you can make it smooth. You can select whatever color you want. Okay, so as you can see the contours are happening. Here the velocity is very high on the upper side, and behind the car it is very low. The blue region, as you can see here, the turbulence is getting generated. Okay, okay, good. I will hide this cut plot for now. I want to make you guys understand about the flow trajectories. What other guys are doing, they just select the plane, okay, and drag it like that, select the 500s of starting points, and it will look like this. Okay, in this you cannot interpret what is happening in the car, so better option, you work smart. Instead of this, what you can do, you can just go to the flow trajectories. If you want to see the flow over your rear wing and the front wing or the front of the car, what you can do, you can select those surfaces and 500 you can give. So what it will do, it will show the flow which is touching or which is going through the selected surfaces. Okay, it will not add any other surfaces. As you can see the Boolean operation is happening. Okay, now you can clearly see the flow of the car. So behind the car vacuum is generating and the turbulence is getting generated. Okay, this phenomena you will learn in the future. Okay, I will explain this phenomena afterwards in the next future videos, and why it is required. Also the dirty air concept I will explain, so you will have the better understanding. I just explained about the how to do the aerodynamic simulation, so that you can start with the simple airfoils. Okay, try different airfoils and try to measure the drag force, down force, and also the turbulence behind it, and the pressure contours you have to study. Okay, so according to that you will develop the overall understanding of the aerodynamics. If you want to pursue your career into aerodynamics, then you can start learning this type of things by different studies. Also a diffuser you can make. Okay, so what it will make a difference behind the car, behind the flow. Okay, and you can make it as an animation. It will look so cool and so good. Okay, it looks so satisfying also. Okay, where the flow is going with the arrow, right? So that's how you can make the simulation. Okay, so this is okay. One more thing I forgot, which is the goal plot. If you want to see the values of that, what you can do, you can just go to the goal plot and show the values. It will deflect over here, average, minimum and maximum. You can take average or maximum values for drag force and down force, and that's how you can calculate the percentage of down force rear wing is carrying, the percentage of down force front wing is carrying, and then calculate the whole car down force and then minus them. Then you can design the front wing and rear wing accordingly, due to according to your track conditions. Okay, so that's how you are going to design the car based on the aerodynamics. So this is all for the video. If you have any doubts, you can just comment down, or else you can text us on Instagram as well. We will surely respond. And if you like the video, please share the video with colleagues. And yes, thank you for watching. Keep sharing, keep learning. See you soon.